Hello friends, this is Rashmi Singh and welcome to my channel Unraveling Science. Solutions for Structure of Atoms, Class 9, Chapter 4. In-text questions. What are canal rays? Canal rays are beam of positively charged ions. It was discovered by Goldstein in 1886. Canal rays are also known as anode rays, and these rays led to the discovery of positively charged subatomic particles called proton. If an atom contains one electron and one proton, will it carry any charge or not? An electron is a negatively charged particle and proton is a positively charged particle. The magnitude of their charges is 0 and therefore the atom will not carry any charge. It will be a neutral atom. On the basis of Thomson's model of an atom, explain how the atom is neutral as a whole. According to Thomson's model of an atom consists of positively charged sphere with negatively charged particles embedded in it. These negative and positive charges are equal in magnitude, so they counterbalance each other's effect and make an atom neutral. On the basis of Rutherford's model of an atom, which subatomic particle is present in the nucleus of an atom? According to Rutherford's model, protons are present in the nucleus of the atom. Draw a sketch of Bohr's model of an atom with 3 shells. Here you can see the sketch. What do you think would be the observation if the alpha particle scattering experiment is carried out using a foil of metal other than gold? If alpha particle scattering experiment is carried out using a foil of any metal as thin as gold foil used by Rutherford, there will be no change in observation. But since other metals are not so malleable, such a thin foil is difficult to obtain. If we use a thick foil, then more alpha particle will bounce back and no idea about the location of positive mass in the atom would be available with such certainty. Name 3 subatomic particles of an atom. The 3 subatomic particles of an atom are protons, neutrons, and electrons. Helium atom has an atomic mass of 4U and 2 protons in its nucleus. How many neutrons does it have? Atomic mass of helium is 4U. Atomic mass is equals to number of proton plus number of neutrons. So, putting the values over here, we get number of neutrons is equals to 4 minus 2, that is 2. So, helium atom has 2 neutrons. Write the distribution of electrons in carbon and sodium atom. Distribution of electrons in carbon atom. So, atomic weight of carbon is 6. So, K shell will have 2 electrons. L shell will have 4 electrons. As you can see in this picture, distribution of electrons in sodium atom, atomic weight of sodium is 11. So, K shell will have 2 electrons, L shell will have 8 electrons and M shell will have 1 electron as shown in the picture. If K and L shells of an atom are full, then what would be the total number of electrons in the atom? The maximum capacity of K shell is 2 electrons and the maximum capacity of L shell is 8 electrons. In total, 2 plus 8 is 10 electrons. So, the total number of electrons in the atom will be 10. How will you find the valency of chlorine, sulfur and magnesium? Valency is the combining capacity of an atom of an element. Chlorine. So, atomic number of chlorine is 17. So, distribution of electron will be 2, 8, 7. So, chlorine need 1 electron to complete its outermost orbit. Hence, its valency is -1 as it gains 1 electron. Sulfur's atomic number is 16, so distribution of electron will be 286. Since sulfur needs 2 electrons to complete its outermost orbit, its valency is -2. Magnesium. Atomic number of magnesium is 12. Distribution of electrons is 282. Magnesium needs to lose 2 electrons from its outermost orbit to become stable, hence its valence is +2, that is it loses 2 electrons. If number of electrons in an atom is 8 and the number of protons is also 8, then what is the atomic number of the atom and what is the charge on the atom? As the atomic number is equals to a number of protons, therefore atomic number of the atom is 8. Since the number of electrons is equals to number of protons, the charge on the atom is 0, that is it is a neutral atom. With the help of table 4.1, find out the mass number of oxygen and sulfur atom. You know, mass number is equals to number of protons plus number of neutrons. So mass number of oxygen will be 8 plus 8, that is 16, and the mass number of sulfur will be 16 plus 16, that is 32. For the symbol H, D and T, tabulate 3 subatomic particles found in each of them. So the symbols H, D and T are isotopes of hydrogen, where H is protium, D is deuterium and T is tritium. So protium will have 1 proton and 1 electron, deuterium will have 1 proton and 1 neutron and 1 electron, and tritium will have 1 proton, 2 neutrons and 1 electron. Write the electronic configuration of any one pair of isotopes and isobars. So the 2 isotopes of carbon are one with mass number 12 and the other with 14. Electronic configuration of both the carbon is 2 and 4, since atomic number is 6 here. 2 isobars are calcium and argon. Electronic configuration of calcium will be 2882, atomic number here is 20. Electronic configuration of argon is 288, since atomic number is 18 here. Exercises. Compare the properties of electrons, protons and neutrons. So the properties are as follows. Electrons are negatively charged, protons are positively charged and neutrons are neutral. Mass of electron is negligible, mass of proton is approximately 2000 times that of electron, and mass of neutron is equal to the mass of proton. Electron is present outside the nucleus in different orbits, and proton and neutrons both are present in the nucleus. What are the limitations of J.J. Thomson's model of atom? The limitations of J.J. Thomson's model of an atom are: it could not explain the result of scattering experiment performed by Rutherford. It did not have any experimental support. What are the limitations of Rutherford's model of an atom? The limitations of Rutherford's model are: it fails to explain the stability of an atom. It doesn't explain the spectrum of hydrogen and other atoms. Describe Bohr's model of the atom. So according to Bohr's model of atom consists of small positively charged nucleus at its center. The whole mass of the atom is concentrated at the nucleus, and the volume of the nucleus is much smaller than the volume of the atom. Nucleus consists of protons and neutrons. Only certain orbits known as discrete orbits of electrons are allowed inside the atom. While revolving in these discrete orbits or shells, electrons do not radiate energy. These shells are represented by letters K, L, M and N as shown in the figure. Compare all the proposed models of an atom given in the chapter. First is Thomson's model. According to this model, atom consists of positively charged sphere and electrons are embedded in it. As shown here in the picture, the negative and the positive charges are equal in magnitude. As a result, the atom is electrically neutral. Next is Rutherford model, according to which atom consists of positively charged center called nucleus. The mass of the atom is contributed mainly by the nucleus. As shown in this picture, the size of the nucleus is very small as compared to the size of the atom. The electrons revolve around the nucleus in a well-defined orbits. Next is Bohr model. According to Bohr's model, Bohr agreed with almost all points of Rutherford except regarding the revolution of electrons, for which he added that there are only certain orbits known as discrete orbits inside the atom in which electrons revolved around the nucleus. Summarize the rules for writing of distribution of electrons in the various shells for the first 18 elements. So the rules of distributing of electrons are: the maximum number of electrons that a shell can accommodate is determined by the formula 2n square, where n is the orbit number. So if n is 1, then 2 into 1 square will be 2. That means first orbit can have maximum of 2 electrons. If n is equals to 2, so 2 into 2 square will be 8. So the second orbit can have maximum of 8 electrons. If n is equals to 3, then 2 multiplied by 3 square is 18. So third orbit can have maximum of 18 electrons. The outermost orbit can hold maximum of 8 electrons. Shells are filled with electrons in the stepwise manner, with inner shells being filled first, followed by the outer shells. Define valency by taking example of silicon and oxygen. So we know that valency is the combining capacity of an atom, specifically how many electrons an atom needs to gain or lose to achieve stable electronic configuration, typically with full outer shell, which is the octet rule. So for silicon, atomic number of silicon is 14, so electronic configuration will be 284. Here silicon needs 4 more electrons to complete its outermost orbit. Therefore, the valency of silicon will be 4. Similarly, for oxygen, atomic number is 8. Electronic configuration will be 2, 6. Here oxygen needed 2 more electrons to complete its outermost orbit. Therefore, the valency of oxygen will be 2. Explain with example atomic number, mass number, isotopes and isobars. Give any 2 uses of isotopes. First, atomic number. The total number of protons present in the atom of an element is called the atomic number of that element. Example, oxygen has 8 protons, thus atomic number of oxygen is 8. Mass number. The sum of the number of protons and the neutrons present in the atom of an element is called the mass number. Example, oxygen has 8 protons and 8 neutrons. Therefore, the mass number of oxygen will be 8 plus 8, that is 16. Isotopes. Isotopes of the are atoms of same elements having same electronic number but different mass number. For example, 3 isotopes of hydrogen are protium, deuterium and tritium. And similarly, isotopes of carbon are one with the mass number 12 and the other with mass number 14. Isobars. Isobars are the atom with same mass number but different atomic number. That is, isobars are atoms of different elements having same mass number. For example, argon, potassium and calcium. The two uses of isotopes are: one isotope of uranium is used as a fuel in nuclear reactor. One isotope of cobalt is used in the treatment of cancer. Sodium ions have completely filled K and L shells. Explain. Atomic number of sodium is 11. So neutral sodium atom has 11 electrons. Then electronic configuration will be 281. Since sodium loses 1 electron to become stable, sodium ion has 10 electrons. So electronic configuration will be now 2,8 and both the shells are completely filled here. If bromine atom is available in the form of say 2 isotopes as shown here, then calculate the average atomic mass of bromine atom. So the average atomic mass of bromine atom is 79 multiplied by 49.7% plus 81 multiplied by 50.3%. So solving this we get 80.006 U. The average atomic mass of a sample of an element X is 16.2 U. What are the percentage of isotopes of X with mass number 16 and X with mass number 18 in the sample? So let the percentage of mass number A16 be X and the percentage of another element with mass number 18 be 100 minus X. So it will be 16 multiplied by 100 upon X plus 18 multiplied by 100 minus X upon 100 is equals to 16.2. Now solving this we get X is equals to 90. So the X element with 16 mass number will be will have 90% and the X number with mass number 18 will have 10% in the sample. If Z is 3, what will be the valency of an atom? Also name the element. So atomic number is 3 here. So electronic configuration will be 2, 1. Since outermost shell has only 1 electron, its valency is 1 and the name of the element is lithium. Composition of the nuclei of two atomic species X and Y are given as under XY. As shown here in the table, the number of protons and neutrons in both X, Y. Give the mass number of X and Y and what is the relation between the two species. So mass number is equals to number of protons plus number of neutrons. Mass number of X will be 6 plus 6 is equals to 12. Mass number of Y will be 6 plus 8 is equals to 14. Atomic number is equals to number of proton. So atomic number of X will be 6 and that of Y is also 6. It is given here in the chart. So since both the species have same atomic number but different mass number, hence they are isotopes. For the following statement, write true and false. J.J. Thomson proposed that the nucleus of an atom contains only nucleons. This is false. A neutron is formed by an electron and the proton combined together. Therefore, it is neutral. This is also false. The mass of an electron is about 1 by 2000 times that of proton. This is true. An isotope of iodine is used for making tincture iodine, which is used as a medicine. This is also false. Rutherford's alpha particle scattering experiment was responsible for the discovery of A. Atomic nucleus, B. Electrons, C. Proton and D. Neutron. The correct answer is atomic nucleus. Isotopes of an element have A. Same physical properties, B. Different chemical properties, C. Different number of neutrons, and D, different atomic number. So the correct answer is C, different number of neutrons. Number of valence electron in chlorine ion are A16, B8, C17 or D18. The correct answer is 8B. Which one of the following is a correct electronic configuration of sodium? A28, B821, C218 or D281. The correct answer is D281. Complete the following table. The table is shown here and the complete table is, you can pause the video and take a look. Thanks for watching. Please do like, share and subscribe.